All right, the next one I'm going to start going through here is this generating a random number between 1 and 26, as it says, represents the letters A through Z in the alphabet. If the number generated is a 1, that's the first letter, 5 is an E, 9 is an I, 15 is an O, and 21 is a U. So if the number that's generated is one of those, add 1 to a vowel count. Otherwise, add 1 to a consonant count. Hardest part of this program was, I guess I can't spell because I didn't know it was consonant. All right, show this program twice. Once with a long, it's not really that long, but with a series of if statements, and again with a switch. All right, so I'm going to do all those. Now, if we look here, notice the first thing I've done is I've added constants. The minimum letter will be 1, which is A. The maximum letter will be 26, which is Z, and num times is the number of times I'm going to run the program. So rather than using 1,000, I'm going to be able to use num times. Does that buy you anything? No. But if I'm using 1,000 in a lot of places in the program, and maybe 1,000 once in a while means this, and maybe later 1,000 means that, etc. By using something like num times, I can make it easier for me to switch everything at one time. So inside of main here, I've got what? I've got a count of my total number of vowels, my total number of consonants, and the current random number. So look at how this changes. Now I'm saying instead of going from 1 to 1,000, go from 1 to num times. All right. The reason that you typically use constants in a program is constants can, this is not a good example, but constants can make your program a little bit more self-documenting. All right. I would suggest when you do the test tomorrow that you use constants. And you'll understand what I mean when you see the test. There are, again, 2 problems on the test. One of them would be much easier if you'd use constants. All right? So I'm saying 1,000 times. So what is this doing? This is, again, generating a random number. You might think that's a little harder to read. If you do, look on the screen, please. That's 26, and that's 1. If that's easier for you to understand, then use 26 and 1. If it's easier for you to understand that that's 1,000, then make it 1,000. I've said this to you before. You are first semester students. You should be programming for understandability. For you. You shouldn't be saying, what's the fastest way I can write this so it'll run as quickly as possible? That's not that important right now. It's really and truly not. All right? So now I'm to the point where I've got a number, and it should be a number between 1 and 26. So I know that if the random number equal 1 or, or the random number is equal to 5. I did that. I did. So if it's a 1, or if it's a 5, or, just copy this, go a little faster that way. So it's 1, 5, 9, 15, and 21. 1, 5, 9, 15, or 21. Again, that's A, that's E, that's I, that's O, and that's U. And the only reason I knew was because I used my fingers to figure it out. Probably could have written a program to tell me what letter it was too, but I didn't do that. I'm looking at the vowels as a collective unit. Yes?
Can you just do
there's a lot of ways it could be done. But I try to make it, it's with a simulation, you know what I'm saying? 1 is A, 5 is E, etc. But yeah, you could have done this in a lot of different ways. Yes. So I know if it is one of those, well, I want to add 1 to my vowel count. I know I've got a vowel. Otherwise, I want to add 1 to my consonant count. Now all I have left to do is the alert, but then we'll go back and we'll look at this with a switch. But I want you to put that in, and again, if you have any questions on this, this is your time to ask. This is very similar to the stuff that you're going to be writing tomorrow. You can do stuff like this, and I believe that Mr. Groves would agree with me here in that, for example, if you were working with games, you are quite often going to be using random numbers. You want random patterns on a screen for something to be moving. You might generate a random number, and figure out something based on that. A 1, 2, 3, or a 4. If it's a 1, you might go up. A 2, you might go down. A 3, you might go right. A 4, you might go left, etc. So there's a lot of ways that this stuff is used, not just in game programming, but in game programming as well. Now, you don't have to do this, but I want to show you something. What I always do in here, and I haven't been doing it because I didn't want there to be a ton of green on the screen here, but I always do this. So in other words, I'm not going to sit there and type in all this stuff or even copy it. So now that does not make the program run any faster, but now I can take it and look quickly at a glance and know, okay, that one goes with this one, etc. All right. The editor even makes it easier for me. These two go together right here, not because they're lined up with one another. This is just because it's the closest one that the system found. All right. But I still remember a case where I had a person who I came in one day and they were already in the classroom and they had about 10 pieces of paper on the floor. I said, "What are you doing?" He said, "Well, I have 77 left curly braces and 76 right ones, and I can't figure out where the other one goes." Well, if you put comments in there, that can make it easier to see what goes with what. All right? Doesn't make the program run any faster. If anything, it might slow it down a little bit. So now, if I'm out of my for loop here, now I can put an alert here that says total number vowels and then total number of consonants. All right. And if I don't have any errors, I will run this in just a minute. And if I don't have any errors, all right, once I go and run it, it should give me X number of vowels. It should be around 200. And X number of consonants, it should be around 800. All right. Did I make any errors? Well, I've shown you so far I'm pretty good at making errors. So there's a good chance that there's one or more errors in here. We'll find out in just a minute. right, so let me go back to here and try to run it and just see if there are errors. Wow, that's the first one I ran that there weren't. All right, so 183 vowels, so 183 times I got a 1, 5, 9, 15, or 21, and 817 times I did not. If this is truly random, I should be able to run it several times, and the numbers won't be exactly the same here. Those were different. Those were different, etc. All right. Now, the only other thing I want to do with this, if you look up on the screen, please, is I said you should write this twice. So now I am going to take this whole thing here and comment it out. And I'm going to rewrite that as a switch statement. All right. So if you want to see whether or not you get that, don't look up on the screen. See if you can start writing it on your own. All right. So I'm taking what was in there and I'm commenting out that if. Oops, sorry, I want another line. That should be the rewrite. Let's make sure it works. And it looks like it does. All right. So that is a rewrite of it using a switch statement. So I took everything in that if, commented it out, and replaced it with what you see there in a switch. Now, you have to look at that yourselves and say, oh, that's easier for me to understand. Then you should use that when you can. But if you say, no, I think that's easier, then use that. It's not that one is necessarily that much more advantageous than the other one is. Christian, you made a comment before about, well, that's dumb that they don't use ranges, etc. It used to be in every programming language, what went in here had to be an integer. It had to be a whole number. You couldn't check strings. Now you can. Because too many people complain because you couldn't. But I mean, imagine that I was generating a number here. Imagine that number I was generating was a 1, a 2, a 3, or a 4. Small, medium, large, extra large. Okay? Then it might very well read easier like this. Because that way I could say case, small, case, etc. Do it that way. But it's the same program regardless of how it's written. All right? Are there any questions on this particular example? No? All right. Then I'm going to close these, and I'm going to go to the other ones that we had in there. Those other ones being from the other folder. Remember, there's 2 folders. So we've just gone over coin flipping, and we went over first are the odds and evens and the vowels. But we have 3 practices. All right, we have 3 practice problems in the other folder. Sorry about that. Grab that other folder. Way too much stuff open. So we've gone through the 3 examples in the still more practice: coin flipping, odds and evens, and vowels. I'm going to go back to this first one. This is the one that I gave you, and I said you didn't have to turn it in, these practice problems. And we're going to look at problem number 1, problem number 2, and problem number 3. You know, are these easier or harder than the ones we did at first? You know, I'll leave that up to you. All right? It's whatever you think. So I'm going to go to problem 1. I'm going to open that up. Here is the HTML, which looks pretty much just like all the other HTMLs that we've done so far. And let's work on the JavaScript. Now, I have to tell you this. Don't look up here, but please listen. Tomorrow, 10 points out of 50 on each of the problems is, did you read and listen and follow the instructions? So, for instance, if you were told use a constant for this, and you don't use a constant, you lose points. Does that make sense? All right. And in fact, I think it's 5 out of 50 on the first one and 10 out of 50 on the second one. So let's just assume that you didn't follow any of those instructions. Even if both your programs work, but you didn't follow the instructions, then the best you can get is an 85. I want everybody in here to get 100. You may or may not believe that, but I, honest to goodness, do. All right? So, write a JavaScript program that converts distances between inches and centimeters. The program must contain a constant named, cm per inch, which holds the numbers of inches in a centimeter, 2.54, so that's this down here. Prompt the user for a distance in inches. I just made these up. So you must give a positive number greater than or equal to 0, and that really should have been greater than 0 because greater than or equal to 0 made no sense, and less than or equal to 1,000,000. Use constants. When the user clicks the convert to centimeters button, display the distance both in inches and in centimeters, as shown in the handout. All right? So, these are our constants. I believe I gave you those. Any questions on what those mean? All right, then let's look in here. Some of this I may or may not have given you. I don't remember. All right, so these, again, these are a combination of a variable declaration and a variable initialization. If you look on the screen, that's a variable declaration, just what's in gray. If you put equals and you give it a value, that's it both, in this case, it is both a declaration and an initialization. All right? So, inches. I want everybody to understand this. What you see up here in gray, this is going to cause an input dialog box to come up that says, please enter a number. It might all be on one line. I don't care. In inches between 1 and 1,000,000. Does that make sense? And I am not giving it any kind of a default value, so there'll just be a box there with nothing in it and a button underneath that says OK, and another button to the right of that that says cancel. All right. What we're going to do then is we're going to check, and if either that is non-numeric, or if it's less than 1, or if it's greater than 1,000,000, I don't want to accept it. That process is known as input validation. So we're about to validate the input. All right. With some programs, you must validate the input. With other ones, no, you don't have to. Okay. So I'm going to come down here now And I'm not going to use an if. I'm going to use a while. So let's take a look at that. And if what I'm doing now doesn't make sense after I get done putting it in, then please ask. Really need that many. I think that'll work. Go ahead and put that in. There's really not a lot to type in the program. There's probably about 5 or 6 more lines. Again, if it's non-numeric, or it's less than 1, or it's greater than 1,000,000. All right. Sometimes when people read this, it's very hard for them to do that, so they like to take this and break it up over 3 different lines. If that's easier for you to read and understand, then do it that way. All right? Whichever way makes more sense to you. All right? Now, if you would, please just stop what you're doing and look on the screen here. Now, I can do this. I literally can come in here now and just paste that in. And that's not a problem. It's fine. However, if I paste that in just like that, all that's going to happen is if I put in something non-numeric or out of range, it's just going to ask me again. And if you've got an end user who's an idiot, they don't know that they've done something wrong. Again, when I say they're an idiot, they're naive. They just don't know. So what I'm going to say here is, again, you don't have to do this, but I'm going to say here, validate the input. And the other thing I'm going to do is before I just give them a message, I'm going to put an alert in here. And I'm going to say, out of range input. Please re-enter. Re-enter. The program will not run any better. It will now run slower. You could say, well, why didn't you tell them they should put in a number between 1 and 1,000,000? Because we're doing it here. We're letting them know there that they put something out of range. Now, we could say, we could check, and we could say if it's not a number, then we could have an alert that says you put in non-numeric. Then we could say else, if it was in here, then we could have said out of range. I'm just having one generic message. All right, so if this makes you feel better, I could say non-numeric or out of range input. That makes it easier for you than put it in like that. But what I want you to understand, if you look on the screen here, is I'm stuck in here until I put in a number that's between 1 and 1,000,000. And if you get that, there's nothing else to get. That is the art of input validation in a nutshell. So once I get down to here, I know I've got a number. All right, so now I have a number between 1 and 1,000,000. So I'm going to figure out my calculations. Centimeters equal inches times cm per inch. That's that thing that we used before. All right, we have one more line, and that's to just print our output. Display output. And if you don't remember what the 2 fixed is, we'll look at it in just a minute. That's the whole program right there. Not in a nutshell. That's it. 42 lines, and out of those 42 lines, what? The first third are documentation. So there's about 30 lines of code in here. Now again, is it possible that I've made an error in here? Of course it is. So I'm going to save this. I'll come right back, and I'm going to run it just to see if I did make any errors. All right, it says please enter a number. I'm just going to test. So I'm going to put in 100. And it says 254. All right, and I believe it was 2.543, so that does look like it worked. Now I'm going to run it again here, and I'm going to put something out of range. Non-numeric or out of range input, please re-enter. That's good. Now I'm going to put in something out of range that way. Same error. 1,000. That's in range. So it looks like it worked. All right. I mean, that's everything right there. And again, if you can write the equivalent of this, I'll take your question in a second. If you can write the equivalent of this, you should do fine on the test tomorrow. Is there a little bit more? Yeah, I'm not going to lie to you. Because I wanted to make you think, too. I didn't want it to be just throw in that pattern. All right? But you're all smart enough people. Believe me, the calculations that you have to do tomorrow are not hard. The ones on your test were much, much harder. All right? Yes?
Is there a reason the cancel button accurately invalid?
What happens is if you click cancel, the system literally believes you want to get out of the operation. You can code and you can check for cancel, and then you can do whatever it is you want to do.
Like the exit button?
There is technically, it's not really an exit. All right. We will end up putting in exit buttons eventually. The other thing too is just so you know this, all right, you don't have to do this, what I'm about to tell you. I want to just show you the simplest way. So let's just say I wanted to be able to run this an unbelievably big number of times. All right? I could literally just put this whole thing here into a loop that told it to run forever. And then it would run and run and run and run and run until I click the button, you know, up here, the X button or whatever. Or I could tell it to run a certain number of times. Or I could, what we're going to end up doing by the end of the week probably, is we'll ask the user after every run, do you want to run the program again? And then based on their input, all right, we're going to take the first letter, we'll tell them to enter a Y or an N, but again, because many users don't read that, if they type in yes, all we want to do is grab the first letter of what they type in. And then we'll uppercase it, and if it's a capital Y, then we'll run it again. Otherwise, we won't. All right? Any questions on anything that's in this example? Like I said, you know, if this is your time to ask. Anything that doesn't make sense in there. All right? Yes. Okay. This means that I want my answer to 2 decimal places. So again, notice that and it's a good question, if I do come in here and run this, and I'm going to stick in a goofy number. It's a stupid number, but I'm going to put pi in there. 3.14156. All right, and it did give me 7.62. All right, and it says 3 inches because I think I made this a parse int. But what that will do is, if it would normally have been 7.623579, it's only going to be 7.62. All right. And again, you can use that at any time, but that is used even more often if you're working with dollars and cents, etc. Anything else? I do want you to understand, just so you see this, don't write this. This is not part of the program. I'm just putting this in here, so don't put this in. If I'm writing a program and I say ++ inches, for example, all right, if I've got these two things on a line by themselves, these two lines that you see in here, it does not matter which you put in there, ++ variable or variable ++. It doesn't matter. They are 100% the same thing. The only time it's different is if I do this. Var x equals this, and var x equals this. Now it's different. What this does is it adds 1 to inches. So if I pretend here for a minute that inches is 9 when I start, it adds 1 to inches, so it's 10. Then it takes 10 and assigns it to x. If I do it this way, it takes what's in inches, which is 9, it assigns that to x, then it adds 1. So to many first-year students, this ++ thing is really confusing. Then never use it. I would never take off if you wrote on here inches equals inches +1 or something like that. That's fine. That's not a problem. Again, I want you to understand what you're doing. That's the most important thing to me right now. All right, let's look at the next one then. Oops, it's not going to do much. So for the second problem, what we're told here is write a program that can convert temperatures from Fahrenheit into both Celsius and Kelvin. All right? Just so you know, you may care, you may not care. This problem right here and the next problem that we're going to go over, those are both problems that were actually assigned to the ASP.NET class because they're learning how to do things in a different way. We give them simple problems like this. So you already know the logic. The logic is the same, regardless of the language you use. What's different is the syntax or the way you go about it. All right. So here are the calculations. So prompt the user for a Fahrenheit temperature that must be greater than or equal to -550. If it's that cold, we're in trouble. And less than or equal to +550. Again, if it's that hot, we're in trouble. But that's fine. Notice I used program constants, and I've got 3 variables, Fahrenheit, Celsius, and Kelvin. So just like we did before, I'm going to come in here, and I'm going to do input validation. And I'm going to come in and say, while is NaN Fahrenheit or the Fahrenheit, oh boy, I can't spell, is less than the min Fahrenheit temperature, or the Fahrenheit is greater than the max Fahrenheit temperature. So I know if any of those things there is true, all right, I know if any of the stuff in here is true, I know that it's an invalid input. So again, just like before, I'm going to say alert, non-numeric or out of range input, please re-enter. And I'm going to grab exactly what I had up here before and paste it in again. All right. So again, once I get down to here, must be a valid Fahrenheit temperature In other words, greater than or equal to negative 550 and less than or equal to positive 550. I know it has to be, because I've kept you in the loop while it's not that. All right, so all I have to do now is my two different temperatures, and I gave them to you right here. And once we do that, just an alert. Now again, I may want to do it two fixed with all of these. I don't know. Just to be safe, I'll put that in like that. But again, you'll notice less than 50 lines. All right. Let me run it again just to make sure, again, there are no errors in here. All right. Is that exactly correct? I don't know. I'll have to go, see if I've got some test values. I know that if I run this, and for instance, if I put in 0 degrees Fahrenheit is like negative 1778 Celsius, all right? And I know that, as an example, if I put in 32 degrees Fahrenheit, that's 0 degrees Celsius. So I know those both worked, all right? And the formula said that Kelvin is Celsius plus 273.15. So it looks like it works. And I should also check non-numeric. Didn't take it. Out of range. Didn't take it. Out of range the other way. Didn't take it. So it looks as though it worked. All right. As far as I can tell, at least, everything worked. Like I said, please, if something does not make sense, please ask. I don't want to ever assume anything as far as what you know, don't know, etc. All right? Let's do the last one then that was left on here, the last problem. And after we do that, we'll take another break, and then I want to go back and go over the test with you, the first two tests that you took. Again, I do have them graded. I'm not going to give them back. I'll give them back tomorrow or Wednesday because I want to look through them and see if, like I said, if everybody missed a certain problem, and I might have to throw that problem out. Last time though, any questions on this? Is there anything that we're doing that doesn't make sense? Now, in your book, they've already done several examples of a miles per gallon program in the book. This last example that I asked you to do does another miles per gallon, but it also figures out not just miles per gallon. It figures out how much your trip cost, and it does that based on the inputs that you put in. So there are more inputs in the last program than there were in the other programs. Since there are more inputs, there's 3 of them. You have to input miles driven, you have to input gallons used, and you have to input price per gallon. You have to input 3 things. So there's going to be 3 times where you do this. Does that make sense to everyone? All right. Because we're going to be validating 3 different pieces of input information. All right? All right. So let's look at the last one then. So again, it's under practice problems, and it's problem 03. So as it says, here you will expand upon the MPG program as follows. I'm not going to read it to you. You already know how to do miles per gallon. All right, so your trip cost is going to be calculated. So if you know you used 30 gallons of gas and that each gallon was $3 a gallon, that was the trip cost was $90. We're not talking about the cost for hotels and souvenirs. No, we don't care about that. And then finally, our cost per mile will be that trip cost divided by the number of miles that we drove. All right? So there is an example. I think I gave that to you on the handout that I gave you. So notice that I've got a bunch more constants, and I made these up. There's nothing special about these. On one of the 2 problems that you have for the test tomorrow, I ask you to make up some constants. They are arbitrary. I made them up. There is nothing significant about the numbers I used. All right, they're just the ones I used. So we're assuming that you must drive between 1 and 1,000 miles. We're assuming that you must use between 1 and 100 gallons of gas, and we are assuming that gas is somewhere between $1 and $4.99. Again, those are just numbers I made up. All right? So if you notice, we are going to input miles driven, we are going to input gallons used, we are going to input price per gallon. These 3 things right here in the gray, those are our inputs. So every one of them, after we read them in, must be validated to make sure they fall within the range that we showed up there. These 3 values are all calculated. So we don't want to do any of these 3 things until we're sure that we put these in and they're valid. And then when we're all done, we'll just output everything. That's what a lot of computer programming is. You input, you process, and you output. All right? So here's our miles driven. And again, just as I have been doing, I'm going to hit enter a few times here. But I'm going to do it the same type of way. In other words, validate miles driven input. So again, just like we've been doing, alert, non-numeric, or out of range input for miles driven. Re-enter. And we'll ask them to do the same thing they've already done right there. So again, look at that. If you have a question, please ask. Yes. That means I spelled something wrong. You are right. Thank you. One nice thing about if you do happen to use this editor, and I'm not pushing it at you at all, and many of them do this, but notice if I highlight that, it shows me the matching one. See that? Which is kind of nice. And again, if it's easier for you to show this over 3 lines, by all means show it over 3 lines. All right? Now, one nice thing about this, if you look up on the screen here, is what I can do right now. It by no means is this program finished, but I can come over to here and I can run it now. And it's asking me, I can check those values. So I'm going to put in a negative number. It didn't take it. I'm going to leave it blank. It didn't take it. I'm going to put in something non-numeric. It didn't take it. I'm going to put in something greater than 1,000. It didn't take it. So I know those checks worked. And, again, you might say that's fine. Then why did you even show us that? There is a reason for it, and the reason is this. Because what I want to do next with gallons used is virtually the same thing. So I'm going to grab every bit of this that's right here, copy it to the clipboard, and I'm going to paste it down here. All right? So now I've already done my input and validate of miles driven. Now I want to do my input and validate of gallons used. So I've got to manually go in now and change all these. I mean, I could use cut and paste, etc. And this will change then from this to gallons used. Oops. And make sure you change all these if you do it this way. So gallons used, oh, there's one missing. Gallons used, min gals, max gal. Okay. I don't think I'm missing anything now. It's really easy if you're going to do a lot of copying and pasting like I just did to miss something. If you would please just look up on the screen here another thing I like about this editor, and it's not unique to this editor. But notice if I take my mouse and I find up here where I find miles driven, if I double click on it, it puts in green everywhere I'm using it. So I know I want to change them all down here. So notice that should be gallons used. See how that's still green? So that one should have been gallons used. I kind of like that because I can make sure then once I've done that that there's nothing that's missed down here. And if I double click on gallons used here, there should be nothing in here that goes green. All right? Doesn't make your program run any better, except it does because it hopefully makes sure you're not making mistakes. So the only thing that's left is price per gallon. So I'm again going to copy what I've done up here. Copy that to the clipboard. Come down to here. And now I want to change all these to price per gallon. And I think I called it min PPG and max PPG, I believe. Yeah, looks like it. And the good news is once we get done with this, we literally have like 4 lines left. Calculate the miles per gallon, calculate the trip cost, calculate the cost per mile, and do your alert. That's all that's left. And again, if I choose to, I can do a 2 fixed on all these. Maybe it'll look a little nicer then. I don't know. And I believe on the handout, where is it? So for this last one, we were supposed to use 200 for miles driven, 8 for gallons used, which should have given us an MPG 25. This would be 0.0, but you get the idea. That should be our MPG. Our trip cost should be $24. And our price per mile should be 12 cents. One thing about this, if there is something about this, I never checked. So, but if I want to put that $sign in there like this, I manually add it. There may be a way to do it other than that, but I don't know exactly what it is. There might be a dollar type that you can use. But the price per gallon, so I'll add a $sign here, and I will add a $sign here for trip cost, and I will add a $sign there for cost per mile. All right. So let's run it and see if we get the same numbers. Make sure we don't have any errors. There's an error. Line 100, unexpected token. Usually that means there's one too many or one too few parentheses. Got that again. All right, we went 200 miles we drove. We used 8 gallons of gas. And the cost per gallon, I don't remember what that was. $3 per gallon. So it says we should have 25 for our miles per gallon. We do. We should have 24 for our trip cost. We do. We should have 12 cents per mile for our cost per mile. And we do. So it looks as though at least that the calculations worked. I'll take your question in a second. One thing I want to say is when you are checking things, you look up on the screen here. So if I say enter a number between 1 and 100, all right? When you start to figure out, okay, how am I going to test this? You should enter at least something out of range. Does that make sense? To make sure that it catches that. Maybe blank. Maybe non-numeric. Numeric. But if you should also enter a few of them that are within range. But once you do that, enter numbers that are easy to figure out the calculations. All right? I'll always remember this. I had a student years ago. They were doing their testing, and I said, "What number did you put in there?" "Oh, I put pi in there to 7 decimal places." What the heck for? You know, I mean, not that there's wrong doing that, but you should check it with stuff that you know you can manually check it easily yourself to see whether it's correct or incorrect. Yes.
So for the currency symbol you're putting in,
yes.
can you not do the currency symbol with a C?
Oh, not like it. No. Again, I've never even checked, so let's see.
I didn't try you.
How could I format numbers? I'd have to look through that.
Yeah.
All right. And there may very well be a way. I don't know. I just never checked. Any questions on that particular problem? All right, then let's come back at 10:30 and we'll take a look at your first 2 tests. I would strongly suggest tomorrow when you're taking the test that you keep one or more of these things open in another window on whatever editor you're using, because it may come in handy